break in the action here. I am currently saw cutting 24 of these things, these raw pieces of stock. I am going to attempt to run 24 of the shift extensions. That is going to be a feat in itself. I'm going to do all 24 first with this. I have everything all set up, ready to go. If you want to see the setup and how I did everything, refer to previous video, card here maybe. If not, it's just a few videos back. So I only need to set up one time and zero the point, zero off of this. And each time I would just, it's easy, you just put the thing in there and tighten it down, let it rip. There's no re-zeroing after this. However, I might use a dial indicator set right here to indicate just if this is off. I can tweak it a little bit with the dead blow hammer. But hopefully everything goes as planned and works out. It's really cold in here. I think I finally got it up to about 55 degrees. It's currently like 16 degrees outside. Everything's just really cold. So after this part gets done profiling, everything's here. I go in, I need to put an optional stop in there just to make the machine stop. And then I can come in here with calipers, measure this shank piece here, because this part gets threaded, so I need to make sure this is nearly exact of what I need it to be in order to thread it correctly. So I look for 0.463 plus or minus 5, really. I think the max I can go is 0.471, and I'm at 0.462, so that'll work. After I measure, I just hit cycle start again, and it goes on with the parting. So here's where things get really cool. In order to run a new part, all I do is chuck the new piece all the way up as far as I can. And this profiling tool here is G54, so that's the work coordinate system for this. In the MDI line, I go G54, because I'm on G55 right now, and G0, rapid move, Y0, Z0. Now that puts it where I want it this way and level. I'm going to bring the raw stock over top of the profiling tool. So I'm over top of the profiling tool. So I release the material just a little bit, and that rests it right up against the profiling tool. So basically resetting my zero height for both tools, because now it thinks it's the same exact as the last one that I just ran, if it's the same Z height here. So then I go ahead and tighten this thing back down as it's resting on the tool here. Tighten it back down. And now I'm just going to make sure that the stock is completely concentric and it's high right there. And I just give it a little tap with the dead blow hammer. We're in the right ballpark there. There's a lot of ridges on this stock piece, so that's why the thing's bouncing up around all over the place. But we're fairly close there, so I'm just going to go roll with that. So I'm going to bring my raw stock over to the insert here and just let it barely scratch it. So there, it's barely scratching the part there, if you can sort of see that in the camera. So my cutting tool needs to be 0.6895 away from the center of the stock, and we're at 0.6896. So I'm just going to call that good, and now we can hit cycle start. Now I've seen guys do that a lot differently in the offsets where they go in and touch Z and that'll change everything here. But it's much easier if you're running multiple parts like this to just zero it off the top of one of the tools that you're using. And that way you don't have to mess around with anything else on the screen, you don't have to mess with any other offsets and risk screwing yourself up next time. So that's sort of just what I'm doing here. So this is finally my last one of this entire run. Ended up running 24, I think I have a few that are scrapped. As for the parting tool, it took me a few tries to get this right. What I found works best is about 875 RPM and about 1.5 inches a minute, and that's how I part this whole thing off. And it is quiet, as you'll see here in a second. Leaving just a little bit left on there so I can wiggle it back and forth and break it off. That way it doesn't fall down in here and get all scuffed up. So that really works well. The parting was literally the hardest part. I went back and forth a bunch of different times trying to figure it out, but really these, I think they turned out really nice. So we had to take a slight little detour here, and I had to remake some soft jaws. And as you saw before, I was getting some terrible chatter with the other soft jaws. which is my mistake. I'm an idiot for even thinking that would work. I went ahead, made new soft jaws. We should be good to go. So we finally have all of the second operation done, which is this one pocketing all the insides here and threading. And now we're going to put these things in here and then thread these down, I think 3/4 of an inch from the top. Those will also be the M12 by 1.25 threads, and these will be thread milled. So nothing to this one. I don't think we'll get a whole lot of chatter just because we're not taking, the thread mill doesn't take barely any of a cut, and I think we'll be alright with the chatter on this one with these Car Smart jaws back in here, and we should be good to go. So let's quickly go over what's going on right here. We are trying to bend this thing to look something similar to this. Now this is one I just did, and I sort of just scrapped it basically because I ran it down too far on this bolt and it got stuck, so I had to pull it off with pliers, and I ended up scrapping it. And it looks burnt. That's because I was trying to pull it off with my gloves and I could not. So we're learning a few things as we go. Now to bend these things I have to apply a little bit of heat, and I do have an oxyacetylene kit set up, and just so happens that every time I get off work it's too late to go to the gas place to get acetylene. So I ended up going to the late great Ace Hardware and picking up one of these. And it works fairly good. I keep it on there, I go around the whole thing for maybe 45 seconds to a minute, and then all I do is put one of my old shift knobs on there, thread it down on, and pull it just a little bit. Now I'm not really gauging how much I'm bending, just enough to where it looks like it's at 30 degrees, somewhere close to 30 degrees. And that's what happens when there's not enough heat. So we finally got it, and got it all bent up and everything, just how it's supposed to look. Basically on the car, this allows people to use the reverse lockout. So for anybody that doesn't really know, to put the car in reverse, this is for a 6-speed transmission, you have to lift up on this little lever thing underneath the shift knob or handle, lift up on that, and then you can put it in reverse. So this allows you to lift up on that and then use whatever shift knob that you want. Mainly all the shift knobs that I've made so far that you've seen in my videos use the reverse lockout. Like this one right here. You lift up in there and that's the little slot for the reverse lockout. And this, however, like I said, allows you to use your own shift knob, whatever that may be. And I assume all shift knobs these days use the M12 by 1.25 because I feel like that's all Ford uses, at least, so I feel like that would be pretty common. But anyway, this is how it came out. A little bit of trial and error on the heating. Wow. So what ended up working best was when I threaded this down on that bolt. And I believe that kept the heat inside of here. When I threaded this down onto that bolt and heated this up around here, then it kept all the heat in within these threads. And I'm going to have to go back all over the threads and just chase these threads and chase these threads as well before I ship these out to people. So if you have any questions, leave them down in the comment section below and I will be sure to answer them, because I know people might have some questions about mill turning or bending of the aluminum or any of that nature. So I think that's it for now. Thanks for watching.